Welcome to the ENOTEC webinar for the SILOTEC 8000. In this webinar, I will explain how the silo safety monitoring system works and its advantages. Coal and pulverized coal are often used as fuel in many different applications for the generation of heat or steam, such as in power, cement or asphalt plants. To ensure a continuous supply of fuel, the coal is stored on site in large silos and cold bunkers that can hold several hundred or even thousands of cubic meters. Coal dust in particular, with its large surface area and high catalytic reactivity, can be easily self-ignited. As a result, there are hundreds of thousands of coal dust silos in the world, with a potential risk of dangerous malfunction due to smoldering fire. Such an undetected smoldering fire would lead to one of the following scenarios. Explosion of the silo, especially when the silo is filled with new coal dust by means of compressed air. An undetected smoldering fire can lead to an explosion of the entire silo if the pressure cannot escape quickly enough. Flash fire, if the combustion of the coal dust is slow, the pressure increase caused by the combustion is discharged through the explosion flaps. 100% smoldering, even if the coal dust only smolders completely without a dangerous risk, this would be an enormous and avoidable cost and interrupt the production process. So, how to maintain safe silo operation? It's the operator's responsibility to analyze potential combustion or explosion risks and take appropriate preventative measures, such as: first of all, to avoid ignition sources, such as non-compliant equipment; constructive explosion protection, such as having explosion flaps or ensuring that the potentially explosive dust does not egress from the silo; to ensure permanent inertization with, for example, nitrogen, carbon dioxide or argon; and with silo monitoring combined with fire extinguishing systems. So which safety monitoring methods are available? First of all, we have the temperature measurement. Here we see the temperature sensors. Temperature measurement is a long-known measuring method and is often used for monitoring silos because of the lower purchasing costs and simple installation. The technical disadvantage is the limited temperature sensing radius, which corresponds more to a point measurement than a representative measurement for the complete silo. It's possible that the coal starts to smolder and the sensor does not measure the temperature increase because it's simply not close enough. In order to compensate for this, many temperature measurements would have to be installed and distributed over the outer walls of the silo, which in turn would lead to an increased installation effort and limit the price advantage of the measuring principle. In case of a temperature increase caused by smoldering coal, the temperature sensors will detect this at some stage, albeit with a delay. This delayed response poses a potential safety risk during this critical time when the inertization process should be initiated. So for these reasons, the temperature measurement is not representative of the gas values inside of the silo. Next, we have the TDLS measurement. The TDLS, or tunable diode laser spectrometer, in the cross-duct version, meets the ATEX requirements and is a fast and representative measuring principle for the detection of smoldering fires in silos. Rather critical is the availability of this analyzer during the silo filling process, usually with compressed air, which is the riskiest operating condition of a silo. During the filling process, compressed air drives the inflammable coal dust into the silo. Newly introduced embers or existing smoldering fires in the silo are actively supplied with oxygen and can possibly ignite. Exactly at this critical moment, when the dust is very dense because of the turbulence caused during the filling process, the laser signal is less stable and therefore less accurate. To correct this problem, The analyzer optics need to be continuously purged with an inert gas, which will not interfere with the measurement, which makes this measuring principle maintenance intensive. The high capital expenditure for the analyzer, as well as the ongoing maintenance requirements, makes the TDLS the most cost-intensive method for silo safety monitoring. Here we have the classical extractive gas analysis. Extractive gas analysis is considered a recognized ATEX-compliant measuring principle which delivers representative silo gas values. Here the sample gas is transported with an ATEX-approved gas sampling probe on the silo roof via a heated sample line to an analyzer cabinet located at floor level. In comparison to TDLS measurement, reliable process data acquisition is also provided during the silo filling phase. The main disadvantage of extractive gas analysis is response delay due to the length of the sample gas line. In case of an emergency, important time for an appropriate reaction on the part of the plant operator is lost. Components which come into contact with the process gas, such as pumps and filters, require increased and continuous maintenance. In addition, not every plant operator is able to provide appropriately trained personnel for a typical maintenance and need to use external companies. Also, the purchase price of this measurement is relatively high, and as described above, is associated with follow-up costs for material and service expenditure. In-situ gas analysis. In-situ gas analysis takes place in close proximity to the process. Here the sampling probe, approved for ATEX Zone 20, is directly connected to the O2 and CO sensors in a housing certified for ATEX Zone 22. The housing is mounted on the silo roof, and the probe protrudes into the silo, ensuring a representative process gas value. Within a few seconds, the CO sensor detects changes in the ppm range, and thus provides an early indication of a smoldering fire. This budget-friendly measuring principle is supplemented by evaluation electronics at ground level. In contrast to the measuring principles presented so far, the ENOTEC in-situ analyzer analyzes the O2 value in the silo in real time. This can be seen as a backup value for the plausibility of the CO sensor, as well as a very good indicator for the quality of the inertization in the silo atmosphere. Due to the benign process gas composition of essentially ambient air compared to a more aggressive flue gas analysis, this measuring principle is considered by ENOTEC to be maintenance-free. So the system meets ATEX requirements and delivers representative silo gas values. The response time is fast as the sensors are directly at the silo. No maintenance is required. The probe is purged automatically by a blowback module when required. The inertization quality is continuously monitored by the additional O2 measurement. The analyzer is budget-friendly and generally requires zero maintenance. Why measure O2 and CO? The most important gas molecule to monitor for smoldering fire protection in a coal silo is CO. The CO is produced when carbon from coal and O2 in the air react during an incomplete combustion. Such a measurement is mandatory in Europe with silo capacities of greater than 120 cubic meters. The second molecule to measure is O2, as it indicates how inert the condition in the silo is, and always is related to the CO concentration if a smoldering fire is present. During a combustion process, the O2 concentration will drop. If CO and O2 are measured simultaneously, smoldering fires can be detected and the efficiency of the inertization is also monitored. SILOTEC 8000 helps to reduce the total inertization time efficiently, which also saves costs. This diagram shows the sequence of events should a smoldering fire occur in a silo. Blue represents the oxygen value in volume percent. Red represents the carbon monoxide value in ppm with a CO limit alarm set to 4000 ppm. First of all, we see a normal and safe silo operation. The plausibility ratio described earlier can be seen when a smoldering fire occurs, the O2 reading drops from near ambient air conditions, and the CO reading rises. When the CO limit value of 4000 ppm is exceeded, SILOTEC 8000 triggers an alarm, and the plant operator starts inerting the silo. The benefits of SILOTEC 8000 go beyond the CO limit value monitoring, which is important from a safety perspective. Using the O2 value, the plant operator can monitor the inertization with regard to speed and quality. He can immediately recognize if the inertization is successful because the O2 value has dropped towards zero, and can stop the injection of inert gas. This allows him to stop the inertization in a targeted and timely manner and save the expensive inert gas. So what is the SILOTEC 8000? SILOTEC measures oxygen and CO directly at the process. The probe is mounted on the silo roof. The electronic unit and blowback module are mounted at the bottom of the silo. The configuration can be seen in the system overview. The probe housing is installed on the silo roof in the ATEX Dust X Zone 22, and the probe is connected to the controller and blowback module. These trends show a typical 24-hour cycle of the SILOTEC measurement in a silo of an asphalt mixing plant. The recording starts with an O2 value between 12 and 13 volume percent O2. The automatic purge to ensure uninterrupted measurement leads to an increase in the O2 value combined with a decrease of the CO value to 0 ppm. After purging the filter, the O2 sensor is automatically calibrated. At about 7 o'clock, one can see the increase of the O2 value when the silo is refilled with new coal dust. In the course of the day, the O2 value continually decreases due to the self-inertization taking place in the silo. The wet coal dust releases its moisture and water vapor is produced, which displaces oxygen. The sudden and short-term increase of the O2 value can possibly be explained by a visual check of the silo filling level. The O2 value continues to decrease until the next purge. In relation to the CO limit alarm of 4000 ppm, very low ppm concentrations in the silo do not indicate a smoldering fire, but they will show the permanent reactive capability of the CO sensor, and its slight changes correlate with the O2 concentration in the silo. So the SILOTEC 8000 is field approved for smoldering fire protection in coal dust silos and offers many benefits. It is representative as a gas measurement for the complete silo. It's compliant with the ATEX Zone 20. It's fast responding to even small changes of the gas composition. It's plug and play, easy to install and does not require maintenance. It is a 24/7 measurement, simultaneously measuring the early warning indicators CO and O2. It reliably triggers the silo inertization and monitors the inertization process. So that's it for the SILOTEC webinar. This is the last in our series of product and application webinars for now. Thank you very much indeed for watching.